Deduce Hamilton principle from D'Alembert's principle. Solution. Let us consider the system which consists of n particles, masses m1, m2, so on mn. Let us assume that the initial configuration with respect to an inertial frame is given by R1, R2, so on Rn. By D'Alembert's principle, we have sigma I varies from 1 to n, small bracket starts fi minus pi dot bracket close delta ri is equal to 0, or sigma I varying from 1 to n pi dot delta ri is equal to sigma I varying from 1 to n fi delta ri, which is equation 1. Left hand term is pi dot delta ri mi ri double dot delta ri, which is equal to d over dt bracket starts mi d ri over dt bracket close delta ri, which is equal to d over dt bracket starts mi d ri over dt into delta ri bracket close minus mi d ri dt d over dt bracket starts delta ri bracket close, which is equation 2. Now delta can be interpreted an operator which produces a small change in ri not connected with time. Both delta and t operators can commute, that is delta small bracket starts dx bracket close is equal to d small bracket starts delta x bracket close. So delta bracket starts dri over dt bracket close is equal to d over dt bracket starts delta ri bracket close. Therefore 2 becomes pi dot delta ri is equal to d over dt bracket starts mi d ri over dt dot delta ri minus mi d ri dt into delta bracket starts dri over dt bracket close, which is equal to d over dt bracket starts mi dri over dt delta ri minus delta square bracket starts 1 upon half mi bracket starts dri over dt bracket close whole square bracket close, which is further equal to d over dt bracket starts mi dri over dt delta ri bracket close minus delta bracket starts 1 upon half mi vi square bracket close. Now putting this equation 1, we get d over dt sigma square bracket starts sigma I bracket starts mi dri over dt bracket close delta ri square bracket close delta bracket starts sigma I is 1 upon half mi vi square bracket close plus sigma I is fi delta ri, which is equation 3. Here sigma I 1 upon half mi vi square is the kinetic energy of T of the system of the particles. If the forces are conservative, then sigma I varying from 1 to n fi delta ri is equal to minus delta v, where v is the potential energy. Thus we have delta bracket start sigma I is varying from 1 to n 1 upon half mi vi square bracket close plus sigma I bring from 1 to n fi delta ri, which is equal to delta t minus delta v, with that is equal to delta bracket starts t minus v bracket close. Now putting this in equation 3, we get d over dt square bracket starts sigma I bracket starts mi dri over dt bracket close into delta ri square bracket close is equal to d bracket starts t minus v bracket close, which is equation 4. Now integrating 4 with respect to the time from the initial time t1 to the final time t2, the motion of we get modulus starts sigma I being from 1 to n mi dri over dt delta ri modulus closed limit t1 to t2 integral t1 to t2 delta bracket starts t minus v bracket close dt, which is equation 5. But delta square bracket starts small bracket starts t minus v bracket close dt square bracket close is equal to delta small bracket starts t minus v bracket close dt plus bracket starts t minus v bracket close delta dt, which is equal to delta bracket starts t minus v bracket close dt. Since delta bracket starts dt bracket close is equal to d bracket starts delta t bracket close is equal to 0, thus integral t1 to t2 delta bracket starts t minus v bracket close dt is equal to delta integral t1 to t2 bracket starts t minus v bracket close dt. Therefore equation 5 becomes modulus starts sigma I varying from 1 to n mi dri over dt into delta ri modulus close limit t1 to t2 integral t1 to t2 delta bracket starts t minus v bracket close dt. To get the Hamilton's principle, we can consider the motion of the system. In delta variation, the process can be considered that all the paths have the same terminal, that is no coordinates variation at the endpoints of the motion. It means that delta ri is 0 at the two ends of the paths for every particle. All the paths are also transverse in the same time. Thus the left hand sides of equation 6 is 0. Therefore from 6 we have delta t1 to t2 bracket starts t minus v dt is 0, which is the Hamilton principle. Putting L is equal to t minus v, we get in delta integral t1 to t2 L dt is equal to 0.